got the B plus in the trig?
But Dad, I tried so hard!
Nathan, let's look at your report card. Asian American Studies, A plus. Oh, that's very good, Nathan. Good job. Japanese 12 AP, A plus. Oh, that's very, very, very good. Rice cooking, A. A Kung Fu AP, A. Well, that's very good. Keeping the family legacy alive. And trigonometry, a B plus. Nathan, that's absolutely unacceptable. How are you going to get to Princeton with a B plus in trigonometry?
I should get a tutor for math. Ah, Trig for you.
Hello, I am Mordechai.
And I am Hans, and together we form the
Trig
Trig
team.
team.
So today we will learn how to graph complex numbers, and then we will learn how to multiply and divide them, and then root them, and then put them to the power of something.
Go math.
Trigonometric notation for complex numbers. Now let's consider a non-zero complex number, a plus bi. Suppose that its absolute value is r. If we let theta be an angle in standard position whose terminal side passes through the point a, b, as shown in the figure, then cosine theta equals a over r, or a equals r cosine theta, and sine theta equals b over r, or b equals r sine theta. Substituting these values for a and b into the a plus bi notation, we get a plus bi equals r cosine theta plus r sine theta I, which equals r cosine theta plus I sine theta. This is trigonometric notation for complex numbers.
Example A, graph 1 plus I. So, you know that the radius is equal to the square root of a squared plus b squared because of the Pythagorean theorem. All you do is just plug it in. R equals the square root of 1 squared plus 1 squared, which is equal to the square root of 2. And to put it into trig notation, you have to put in sine cosine, and you know that sine theta is equal to b over r, which is equal to 1 over root 2, or root 2 over 2. And cosine theta is equal to a over r, which is equal to 1 over root 2, or root 2 over 2. So in the end, you know that 1 plus I is equal to root 2 times the quantity of cosine pi over 4 plus I sine pi over 4. Or 1 plus I equals root 2 times the quantity of cosine 45 degrees plus I sine 45 degrees.
Multiplying complex numbers. The formula for multiplying complex numbers is r1 times the quantity cosine theta 1 plus I sine theta 1 times r2 times quantity cosine theta 2 plus I sine theta 2, which equals r1 times r2 times quantity cosine theta 1 plus theta 2 plus I sine theta 1 plus theta 2.
Let's do an example. 3 cosine 40 plus I sine 40 times 4 cosine 20 plus I sine 20. So what we're going to do here is add them together. So then it'll be 3 times 4 cosine 40 plus 20 plus I sine 40 plus 20. And after that, we multiply the 3 by 4 and then add up the 40 and 20, which will become 12 cosine 60 plus I sine 60. After that, we'll convert it, and it'll become 12 1/2 plus root 3 over 2I, and then it'll become 6 plus 6 root 3I.
Dividing complex numbers. The formula for dividing complex numbers is r1 cosine theta plus I sine theta divided by r2 cosine theta 2 plus I sine theta 2, or r1 over r2 cosine theta 1 minus theta 2 plus I sine theta 1 minus theta 2.
So, dividing 1 plus I over 1 minus I. First, we must put in trigonometric trig notation. So, 1 plus I is equal to root 2 times quantity of cosine of 45 degrees plus I sine of 45 degrees. And 1 minus I is equal to root 2 times the quantity of cosine of 315 degrees plus I sine of 315 degrees. So, we have is root 2 times the quantity of cosine 45 degrees plus I sine 45 degrees all over root 2 times the quantity of cosine of 315 degrees plus I sine of 315 degrees. Continued, we have 1 times the quantity of cosine of 45 degrees minus 315 degrees plus I sine of 45 degrees minus 315 degrees, which becomes cosine of negative 270 degrees plus I sine of negative 270 degrees, which is equal to 0 plus I times 1, which is equal to I. Powers of complex numbers. To figure out the theorem for powers of complex numbers, here's a proof. So here we have r times cosine theta plus I sine theta squared is the same thing as r times the quantity of cosine theta plus I sine theta times r times the cosine theta plus I sine theta. So we know that that is r times the quantity of cosine theta plus I sine of theta plus theta, which is equal to r squared times the quantity of cosine of 2 theta plus I sine of 2 theta. From this, we can deduct de Moivre's theorem, which states that r times the quantity of cosine theta plus I sine theta to the n is equal to r to the n times the quantity of cosine of n theta plus I sine of n theta.
An example problem for taking the power of complex numbers. So here we have trigonometric notation. So, and we know that the triangle is like hypotenuse is root 2. So we get root 2 cosine 45 plus I sine 45. Then we apply de Moivre's theorem, and so we get 2 to the power of 9 over 2 times cosine 9 times 45 degrees plus I sine 9 times 45 degrees, which turns into 16 root 2 cosine 45 degrees plus I sine 45 degrees, which becomes 16 root 2 root 2 over 2 plus I root 2 over 2, which finally becomes 16 plus 16i. R to the power of 1 times cosine plus k times 360 over n plus I sine theta over n plus k times 360 over n, where n equals the degree of the root, and k is, so you plug in a different value, so it's like 0, 1, 2, and you go up this one.
Dad, what are you talking about? I have 109% in class. Where'd you get a B plus from? Dad! Dad!
Nathan, be quiet! I can tell you are more important than your grades. Carry on my wayward son. There'll be peace when you are done. There'll be baby hands in breast. Don't you cry no more.